Hi everyone, my name is Pyo. Welcome to my channel. Today, I'm going to talk about the fundamentals of computational fluid dynamics that are booming in the current design industry. Computational fluid dynamics is the studies of how fluids flow using computer. To understand the fluid's behaviors, we must understand the governing mathematical equation because it can explain the fluid's flow. But typically, they are too complicated to solve by using the hand calculation, so the mathematics has to be used the computer. I'm sure this video is very suitable for the complete beginner of CFD and also for the undergraduate and postgraduate engineering students that are learning about the CFD and also for the engineer that are working in the design industry, especially with fluid-related machine. In order to explain about the CFD, I'm divided into three main parts, and I'm also made the video for each one. In part one video, this one, I'm gonna be talking about the definition of CFD, and how they are becoming popular in the design industry with the historical background, and then they are becoming popular. What types of application is firstly used in the design industry, and then we go to the application of CFD and what types of benefit do we get by using the CFD analysis with the many examples of engineering fields, and then what are the essential requirements to do the efficient CFD simulation. In part 2 video, there will be the basic theories and governing mathematical equations that we need to know and consider this factor in the CFD analysis. So firstly, I will be introduced with the discretization process, sometimes called meshing. Meshing is very, very important in every engineering design simulation. And then boundary condition. Boundary condition is like the environmental condition that our designers will be encountered when they are working. I mean, the environment is like environmental condition, environmental temperature, and velocity, viscosity, and many other physical behavior that will be have beside the working process. Also for the numerical method that I used to solve the governing mathematical equation, like the Navier-Stokes equation. After that, I'm going to be talk about the data visualization that we got after doing the simulation and to see clearly. Most of the fluid flow in the real world condition is turbulent. So we must be fully understand about the characteristic of CFD. We cannot be explain about it. I'm carefully prepared for the part 2 video, able to include all of the mostly used technical team in the CFD, able to learn for the CFD after watching this video. In part 3 video, I have to demonstrate how to apply the theories and mathematical equations that I talk in the part 2 video in the accurate CFD simulation. To do that, I was prepared for two types of CFD simulation. With the lift driving cavity flow problem. Actually, this types of problem is usually used to analyze how precise our used numerical method with the other method. When comparing the numerical method accuracy, this types of problem is usually used to test their method. So first one is the numerical analysis with the computer coding, and then with the second one is the CA software like Axis, then compare the result data, how they are differ.